Metro North Station of Greenwich, Connecticut has 2,804 commuters. Find the best predicted value, best predicted number of parking spots at that station. So we have 8 ordered pairs from 8 different commuter stations and how many parking places each one of those stations has. First thing we want to check is, does the scatter plot suggest that the data appears to have a linear relationship? I've already entered that data into list 1 and list 2, and I created the scatter plot here. When I just graphed the scatter plot, of course, it didn't have the line showing yet, but even without it, I could tell that it looks like the more commuters a station has, the more parking places the station has. That makes sense. So yes, the scatter plot looks like there's a linear relationship between commuters and parking spots. Find the value of R and its p-value. I have done the linear regression t-test, and I found the value of R to 3 decimal places to be 0.901. And scrolling back up so that I can see the p-value, the p-value was 0.002, or I think in my math lab it may say round to 4 decimal places, in which case that would be 0.0022. Find the critical values from R from the table of critical values, which you just click the icon in My Math Lab and that table pops up. But it's the same as for the previous example because we still have 8 ordered pairs. And as we've done in the past, when no significance level is given, we're going to use alpha equals 0.05. So just like the previous example, the critical value was 0.707. Does R indicate that there is a linear relationship among the variables? Well, our R value was 0.901. Our critical value was 0.707. And once again, that R value is greater than the critical value. So yes, R does indicate that there is a linear relationship among the variables. We're trying to predict the number of parking places at Greenwich, Connecticut, Metro North Station. It has 2,804 commuters. That's my X value, and it is within the scope of these other stations' number of commuters. So yes, the prediction is within the scope of the sample data. The regression of the equation of the regression line. I have my values of A and B that I can substitute into the regression equation. A is approximately 89.5. And B, rounded to 3 decimal places, is 0.409. And that's my slope, so that's the coefficient of X. When I graphed that regression line on top of my scatter plot, it looks like the regression line fits that scatter plot very well. And all of these questions that I've answered, yes, the scatter plot looks linear. Yes, the R value indicates that there is a linear correlation. My prediction is within the scope of the sample data, and the regression line fits the points well. All of those yeses mean that I can use the regression line to make my prediction. The value of the regression equation for X equals 2,804. That means put 2,804 in place of X. And let me do that very quickly. To the nearest whole parking space, I get 1,236. Should I use that value from the regression equation, or should I find the mean of the sample y's? Again, all of those questions I answered yes tells me that I can use the regression equation. And so the predicted parking spots for 2,804 commuters in the Metro North Station of Greenwich, Connecticut is 1,236. The actual number of parking spots at that station is 1,274. That was a pretty good prediction. What we expected is very close to the actual number of parking spaces at Metro North.